Lesson 55, Advanced Abstract Equations and Word Problems in Quadratic Equations. We have worked with advanced abstract equations before. An advanced abstract equation is an equation that contains many variables but has no numerical answer. An abstract advanced equation is an equation that contains many variables but has no numerical answer, no numerical values. We're going to do a couple of these examples together just to refresh your memory, and then I'm going to leave one for you. In the first one, we're going to solve for m in the equation a plus b over x plus y over m equals k. Now, in these problems, you will have to distribute in order to find the answer. So everything needs to be distributed completely in these problems. Previously, you didn't have to distribute, but in these, you're going to need to do that. All right, so in this equation, we're solving for m. When we have an equation where we have terms in the denominator, and we've got it set equal to something, we want to get rid of those denominator terms. So we're going to multiply through by a common denominator. And in this case, a common denominator would be xm. So we're going to multiply each term through by xm. We can cross out variables, cross cancel variables. So in this first one, we're going to cross cancel the x. If I distribute that m in, I'm going to have am plus bm. In the next term, I'm going to cancel an m. It's going to be plus xy. And it's going to be equal to kmx. Now we are solving for m, so we need to isolate that variable. We need to get it by itself. So I'm going to get m by itself, and everything else I'm going to move to the other side of the equation. So I'm going to subtract xy from both sides, but I'm also going to subtract kmx from both sides. So I'm going to have am plus bm minus kmx equals negative xy. In order to solve for that m, we need to get it out by itself, so we're going to factor an m, and I'm left with a plus b minus kx equals negative xy. And then to get that m by itself, we divide by a plus b minus kx. So the solution is negative xy over a plus b minus kx. All right, let's look at a second one. In this second example, we're going to solve for x in the equation mp over c plus d plus e over x equals d. We're going to solve for x. All right, so the first thing that we do in order to get rid of those fractions is we multiply through by a common denominator. Common in this case is going to be cx. So I'm going to multiply everything through by cx. In my first term, the c's can cancel out, and I'm left with mpx. In the next term, my x's cancel out, and this c needs to be distributed to d plus e. So I'm going to end up with plus cd plus ce. And it's going to be equal to c dx. Again, I'm trying to solve for x, so I want to get all the x's on one side and everything else on the other. So I'm going to subtract mpx, which leaves me with cd plus ce equals cdx minus mpx. We're trying to isolate that x, so we need to pull that x out. So I'm going to factor an x out. When I factor, I get cd minus mp. And to isolate that x, we divide by cd minus mp. And that is the final solution. Now note, in the solution we have CD plus CE over CD minus MP. Those CDs cannot cancel out because they have to be in every single term. So since there's not a CD along with this E, and there's not a CD along with this MP, we can't cancel the terms out, so the solution remains CD plus CE over CD minus MP. Alright, I'm going to write one more example up on the board. This example, I want you to go ahead and try on your own. In this example, we're going to solve for A. And the equation is mx over y plus d over a plus b equals p. Solve this one the same way. You're just going to have a little extra step when it comes to cross-canceling your variables. All right, so go ahead and pause the video and work this one out on your own. When you finish, go ahead and resume. All right, the next thing we're going to talk about is word problems and quadratic equations. I have a word problem up on the board, and you'll notice that it is a consecutive integer problem. Find 3 consecutive integers such that the product of the first and the third is 4 greater than 4 times the second. In these consecutive integer problems, oftentimes we'll have two integers that are multiplied, and that will lead me to a quadratic equation, or that will lead me to a variable that's squared. So what we're going to do is we're going to work this problem out together. So if you go ahead and want to take a moment just to copy the problem down, find 3 consecutive integers such that the product of the first and the third is 4 greater than 4 times the second. Just as we normally do in consecutive integer word problems, we want to start off with our let statements. We're finding 3 consecutive integers, so these are just 3 numbers right next to each other on the number line. So I'm going to let x equal my first, x plus 1 is going to equal my second, and x plus 2 is going to equal the third. Alright, so from there we're going to go ahead and set up our equation. It says find 3 consecutive integers such that the product of the first and the third. So we're multiplying the first, which is x, times the third, which is x plus 2. Alright, so the product of the first and the third is, so this equals 4 greater than 4 times the second. So I'm going to go ahead and do 4 times the second first. So that's 4 times x plus 1. And it's 4 greater than that, so I'm going to add 4 to the end. You could add 4 to the beginning of that as well if you wanted to. Alright, so now what we're going to do is we're going to solve for x. Well, you'll notice here in the very first part of the problem we have x times x, which leaves me with x squared. This means that we have a quadratic. So what's going to happen when we get a solution is that we're going to have 2 sets of solutions. We're going to have 2 sets of consecutive integers. Alright, so we have x squared plus 2x. And that's going to be equal to 4x plus 4 plus 4. Our goal in solving these problems is to go ahead, we want to try to see if we can factor first. So in order to factor, we need to get everything on one side and we're going to set it equal to 0. So I'm going to combine like terms and move everything to the left side of my equation. So I'm going to subtract 4x. And I'm also going to subtract 8 because 4 plus 4 is 8. So my equation is now x squared minus 2x minus 8 equals 0. So we want to determine, can x squared minus 2x minus 8 be factored? Well, are there factors of 8 that multiply to give me 8 but add or subtract to give me 2? And that is, we do have factors of 8. That would be 4 and 2. So now we just need to figure out our signs. Well, there's a negative in the back, so one's going to be plus and one's going to be minus. And the middle term always tells us which term is going to go with the bigger number. So our 4 is going to be negative and our 2 is going to be positive. Now keep in mind when we're solving for x, everything is equal to 0. So my 2 solutions are x plus 2 equals 0, and I also have x minus 4 equals 0. So what plus 2 gives me 0? Well, that's negative 2, which means that my other integers are negative 1 and 0, because negative 2 plus 1 is negative 1, negative 2 plus 2 is 0. And when I have x minus 4 equals 0, that means x is 4, which means 5 and 6 are my consecutive integers. So the solutions to this consecutive integer problem are x equals -2, -1, 0, and x also equals 4, 5, and 6. All right, I would like for you to do one more example. This one I'm going to write out for you. Don't have it written out. I'm going to go ahead and try this one on your own, and we will check it when we come into class. Find 3 consecutive integers such that the product of the first and the third is 5 greater than 5 times the second. Go ahead and finish writing that one down, and then solve it on your own, and we will check it in class.